Hello student, welcome to the one more session of Computer Network and Security. This is Vasan Naik from Canara Engineering College. In my previous session, we have discussed about private key or asymmetric key cryptography. So in asymmetric key cryptography, we have discussed the various algorithms like DES and Advanced Encryption Standard Algorithm. In this session, you will see what is public key cryptography. As I told in my earlier session, the public key cryptography is the technique which makes use of two keys. That is, one is a public and second one is called as a private. With the context to the symmetric key encryption, it makes use of only one key, that is a single key shared between a sender and a receiver. But in case of public key cryptography, it will make use of two keys. So this makes use of two keys for every simplex logical communication link, that is public key and private key. Now what is the meaning of simplex logical communication link? Let me take you to the blackboard. Suppose the user, we have two users wants to communicate. User A wants to communicate with the user B. Then user A will use two keys, let us say key 1 and key 2, for this simplex communication between A to B. Similarly, user B on the other end will use two keys, that is K3 and K4 for the simplex communication channel. Totally user A and B will use K1, K2, K3 and K4. This in other way I can write. This is the user A. This is the user A. So the user A generate two keys. One is called as KUA, that is the public key of A, and other one is called as KRA, that is the private key of A. Now user B will generate two keys, that is KUB, public key of B, and KRB, private key of B. So when the node generate a set of keys, that is public key and private key, there is a relation between these two keys, that is any of these keys can be used to encrypt the message. That is, the user A can use either is public key to encrypt the message or private key to encrypt the message. For example, user A, we have user A and associated key is KUA and KRA is generated with the user A node, and this has got a relation in such a way that suppose user A encrypt the message, this is the plain text. If we encrypt the message by using say KUA, public key of A, then it is called as ciphertext. Then the ciphertext can be decrypted by using the private key of A, decrypted by using the private key of A to get the original message. So in this way the keys are related. On the other hand, suppose this is the plain text and this plain text is encrypted by using private key of A to generate ciphertext. Now the ciphertext can be decrypted by using public key of A to get back the original message. So this is the relation between a key. So normally public key will be made open to the public and a private key will be with the particular sender or receiver. depending on the where the key is generated. So this asymmetric key system uses two keys. One is called as a public key, other one is called as a private key. Now what are the applications of this public key system, asymmetric key or public key cryptography? The applications of public key cryptography is confidentiality, key distribution and authentication. So we in the next slide will see how public key cryptography can be used to adopt confidentiality and authentication. Before proceeding to the application, we will see now what are the ingredients of the public key crypto system. The main ingredients of the public key crypto systems is plain text, the message to be encrypted, the public key and private key, that is KU and KR, one with the sender and other with the receiver, ciphertext, the message after the encryption, encryption algorithm that makes use of private key and that makes use of plain text and one of the key, and decryption algorithm that makes use of ciphertext and one of the key. Now the application of this system is one is encryption and decryption. The sender encrypts the message with the receiver's public key. Second one is type of authentication, or we can call it as a digital signature. The sender signs the message with its private key, and the third application is which is also called as third application is key exchange. Students, now we will see the first application, that is confidentiality. That is, sender want to send the message to the receiver in secured way. Here you can see the sender who has got the public key of B will encrypt the message and send the ciphertext to the receiver. On the other end, when the receiver receives the ciphertext, receiver can decrypt the ciphertext because receiver has got corresponding private key. Receiver B has got corresponding private key. So only the receiver B can decrypt the message. So this serves as a encryption purpose. That is, the message is sent from sender to receiver securely. No other. So if the intruder in between hack the message, the intruder will not decrypt the message because the corresponding private key is with the B only. Now one more application of this private key, public key cryptography system is authentication. Here the sender sends the message by encrypting the sender's private key with the sender's private key, and sender will send the message to the receiver B. Now the receiver B can decrypt the message with the sender's public key, as the receiver B has got sender's public key. So to decrypt the message sent by the sender A, it needs receiver's sender's private public key. So B has got sender's public key, so B can decrypt the message, and with this B will come to know that the message is sent by authorized user. So this serves as authentication purpose. Here the secrecy of the message is not important. For example, if the message, if this message is received by the other user who are having the public key of A, they can also decrypt the message. But this message, the secrecy of the message is not important here. The authentication is important, so that B here can confirm that the message has come from A only, because the message is decrypted. The message is decrypted by using A's public key. That is that will serve as the authentication purpose. The third application of this one is key distribution. So the one of the main disadvantage of a symmetric key cryptographic system is the both sender and receiver will use the same key, but the symmetric key crypto systems are faster than public key or asymmetric key crypto systems. So by using public key crypto system, sender and receiver can share the key securely and continue with the symmetric key crypto system. So now we'll see the algorithm related to the public key crypto system. The algorithm name is called as RSA. So RSA was named after the inventors Rivest, Shamir and Edelman. Is a widely accepted scheme for public key crypto system. So how this RSA works? So RSA is developed by Rivest, Shamir and Edelman in 1977. It is a block cipher. In my earlier video, I told you I have explained the difference between block cipher and stream cipher, and it is mostly widely implemented algorithm. So how the keys are generated in this case? So how the keys are generated in this case? First we will see how the keys are generated by using RSA. So here the 7 steps are there. The first step is select two large numbers P and Q. Both P and Q are prime number. Both P and Q are prime number. Then second step, calculate the product of P and Q, that is n is equal to P into Q. So since P and Q are both are prime number and a large number, so the product of P and Q is also a very big number. Third step is calculate phi of n. Phi of n is also called as Euler tangent. So is equal to P minus 1 and Q minus 1. Now what is this phi of n, or what is this Euler tangent? So this is the number of this indicates the number of positive numbers less than n and relatively prime to n. Relatively prime to n. Now in the fourth step, select integer e such that GCD of phi of n and e is equal to 1, where e is equal to 1 less than 1 and less than phi of n. E lies between 1 and phi of n. Then the fifth step involves calculate d in such a way that d is equal to e inverse of 1 mod phi of n. Once you calculate d and e, then the public key can be written as e comma n, and private key is d comma n. So please students, please note here n is a very big number. It is a part of key. So here in our case P is known, Q is known, N is known, but we need to keep E and D as a secret. So now the next stage is encryption. So how to encrypt? So let us take the plain text is M. So in my previous video I have explained RSA or DES makes use of block cipher. It is a block cipher. That means it makes use of various blocks. It makes use of blocks of data, or blocks of data will be encrypted at a time. So let me explain this one with the help of this diagram. So this is the data. So we will divide the data into different blocks. This is the block 1, block 2, block 3, block 4. The size of the block, so now we will treat this block as an integer. Now we have to treat this block as an integer. Say let us call this m in such a way that m should be less than n. The size of the block should be less than n. The size of the block should be less than n. So first take the plain text block wise, and the size of the block should be less than n. Then raise m to the power e is a part of a public key or a private key. You can use any one of the key into mod n. That will gives ciphertext. Once this is over, then decryption stage. In the decryption stage, we will take ciphertext. Now raise the ciphertext C to the power D into mod n. That will give the plain text. Here we are taking the plain text M, and I will take any one of the key and I will raise the plain text to that power of E, and this is nothing but our ciphertext. While decrypting, I will raise this ciphertext C into the power of D, that is M is equal to ED. Since we have selected ED is equal to 1, so it ultimately leads to M raised to the power 1 or nothing but M itself. So you will get the original text after decryption. So now we will try to use the RSA algorithm and we will try to solve the problem. So here you can see, select two prime numbers, P is equal to 7 and Q is equal to 7. Now you have to calculate n. N is a very large big number. P into Q, that is 7 into 7, that is 119. Calculate phi of n is nothing but P minus 1 and Q minus 1, that is 96. And select E such that is relatively prime to phi of n. In our case, we will select E is equal to 5. Now we know D is equal to 1 mod 96. So we will try to find out the value of D. D is 77. In this case, D is 77 because 77 into 5, 77 5 is 385. That is nothing but 4 into 96 plus 1. So now the public key is 5,119 and private key is 77,119. Once we find out public and private key, next step is encryption and decryption process. Here you can see the plain text first M is raised to the power 5 mod 119, and this, when you solve this one, you will get ciphertext is equal to 66. Then decryption process is 66 raised to the power 77. So 66 raised to the power 77 yields to very large number. So this need to be solved by particular technique. So 66 raised to the power 77 mod 119 gives answer 19. That is, we got our plain text back. So when we talk about the security of the RSA algorithm, the security of the RSA algorithms compared to DS algorithm is very large, very high. That is because DS algorithm makes use of 56-bit key, but our RSA algorithms makes use of 1024-bit key. The standard latest RSA algorithm makes use of 1024-bit key. That means it's a very large number in terms of 300 to 400 digits. And we know P is a very large number, Q is very large number, and the product of P and Q, that is very large number. Now, even if the hacker tries to hack the system, hacker knows about P and hacker knows about N, but by knowing very large number, it is very difficult to find out the prime factor of N. And it is found that, according to the studies, it is found that it is computationally impossible according to the present processing capabilities of the machine. So the next concept here is key generation. So to key generation, we are using Diffie element exchange algorithm. This is the algorithm is the alternative to the key distribution using KDC. So this Diffie element key exchange algorithm was proposed in 1976. So the name Diffie element came because of the proposer. It allows a group of users to agree on secret key over the insecure channel, and this algorithm cannot be used for encryption or decryption purpose. So let's see now how this algorithm works. Here A and B wants to agree on the secret key. So A and B first they agree on two large numbers n and g such that g lies between 1 and n. A choose a random number x and computes x is equal to g raised to power x mod n, and A sends that value of x to B. B chooses random number y and computes y is equal to g raised to power y into mod n and send that value to A. Now A computes y x mod n and B computes x y mod n. In fact here, so A computes K1 is equal to y, that is capital Y, K1 is equal to y x mod n. So what is the value of x here? That is the value of x is equal to so A computes K1 is equal to yx mod n. So we know the value of y here, the value of y is equal to gy mod n. Let us substitute that value, gy, and we will get x mod n, that is we will get g raised to power xy mod n. Similarly K2 is equal to xy mod n. We know what is the value of x here. X is nothing but g raised to power x and y mod n, that is nothing but g is equal to g raised to power xy mod n. Now this shows that both K1 and K2 are now same. In this way both parties can share the key and they can continue the encrypting the data by using secret key encryption technique or symmetric key encryption technique rather than a public key encryption technique, because the main drawback of the public key encryption is it is slower. So by using this technique, defilement technique, they can both parties can share agree upon the secret key, and they can continue the encryption of message by using symmetric key encryption technique. So same process are illustrated in graphically here. Here you can see the user A, X and Y. Sorry, user A and B. So user A choose the number X, user B choose the number Y. User A calculate capital X is nothing but G raised to power X mod n and send that to the B. B calculate capital Y, that is nothing but G raised to power Y mod n and send it to A. Finally A will compute YX mod n and B will compute XY mod n. So in this way both will come to the conclusion of same key. So this is the one of the very important concept of key exchange. So in the next session we will see some of the problem related to RSA. Thank you.